Okay, let's try a couple of practice problems here. We're in chapter 1, section 4. We just got done talking about you can solve math problems in many different ways. It doesn't have to be only one way. There are different ways to do something. So let's just try practice that skill with these 6 problems here. I'll do a couple of them for you to show you how they go. Go ahead and pause the video and try 4, 5, 6, 7, 8, and 9 and see if you match what I get. Okay, let's look at number 4. We got 3 times x plus 1 plus 6 equals negative 9. Now you could do the distribute 3, but I know that when I subtract 6 over, I'm still going to have a number that's divisible by 3, so I'm going to just do the subtract 6 and not simplify over here. That's negative 15. Then I can divide both sides by 3 to get rid of that 3, reduces to 1s. That leaves me with x plus 1 equals negative 5 minus 1, x equals negative 6. Let's look at number 5. Okay, number 5. 15 equals 5 plus 4 times 2d minus 3. When I subtract 5 from both sides, I get 10. That's not divisible by 4, so I'm going to go ahead and distribute inside here. So now that's 5 plus 8d minus 12. My like terms are 5 and negative 12, leaves me negative 7 plus 8d. If I add my 7 over to both sides, I get 22 equals 8d. Get rid of my 8, reduces to 1s, leaves me with d equals 22 eighths. And then I reduce that, make sure you always reduce to the smallest fraction possible. Okay, there's those couple right there. Let's see if I can delete these really quickly. Okay, that was pretty close. Let's go ahead and try 6. 13 equals negative 2 times y minus 4 plus 3y. I've got 2 y's on this side, so I am going to do the distribute because I need to do those like terms, so I get only one set of y's. 13 equals negative 2y plus 8. Negative times negative makes positive. And then plus 3y. 13 equals negative 2y and 3y is just 1y plus 8. Subtract the 8. 5 equals the y. And we should be plugging these in and checking to make sure that they are correct. Let's try number 7. 2x times 5 minus 3 minus 3x equals 5. Again, I've got x terms on both, multiple terms on the same side, so I'm going to do the distribute. 10x minus 6x minus 3x equals 5. 4x minus 3x equals 5. X equals 5. I can plug that back into C. Let's see. 2 times 5 is 10. 5 minus 3 is 2. So 10 times 2 is 20. 5 times 3 is 15. 20 minus 15 is 5. Fantastic. And I just noticed that we could have done those like terms and just gotten 2 and gotten 4x minus 3x equals 5 and then gotten x equals 5. Could have saved us a little bit there. So that's pretty good. Let's see if I can delete all of those guys. Gotta hold it long enough. Maybe if I use my big, needed the finger. All right, 8. Negative 4 times 2m plus 5 minus 3m equals 35. I'm going to distribute. Negative 8m minus 20 minus 3m equals 35. Negative 11m minus 20 equals 35. Add 20. Negative 11m equals 55. Divide by negative 11. M equals negative 5. And we'll do 9 in green. 5 times 3 minus x plus 2 times 3 minus x equals 14. Now I'm going to do something interesting here. Yeah, well, that'll work. Notice that they both have a 3 minus x. We can actually factor that out. Leaves us with 5 plus 2 equals 14. 3 minus x, 5 plus 2 is 7. Minus 14. They're multiplying, so I can divide by 7 both sides. Reduces to 1. Leaves me with 3 minus x. And 14 divided by 7 is 2. And then if I do minus 3 on both sides, negative x equals negative 1. And then if I divide by a negative, x equals 1. And I could plug it back in. See, 3 minus 1 is 2. So 2 times 5 is 10. 2 times 2 is 4. 10 plus 4 is 14. And it works and checks out. Okay. Solving a real life problem. Here's just word problem. So taking what we've been doing and doing that. So we're going to create an equation. Then we're going to do multiple steps to solve. Use the table to find the number of miles x you need to bike on Friday so that the mean number of miles biked per day is 5. Is 5. The is the equal sign. So whatever it is has to equal 5. And we need to know about the mean. Mean is the average. And to average, we add them all up and we divide by how many we have. So we take 3.5 plus 5.5 plus 0 plus 5 plus x. And I've got 1, 2, 3, 4, 5 things. So I'm going to divide by 5. And it's supposed to be is 5 equals 5. So 3.5 and 5.5 makes 9. Plus 0 is still 9. Plus 5 is 14. Plus x over 5 equals 5. Now we're dividing by 5. And I want to undo divide by 5. So I'm going to multiply by 5. If I do it to that side, got to do it to this side. 5 on top, 5 on bottom, reduces to 1s, leaves me with 14 plus x equals 25. Move that 14, x equals 11. Got to bike 11 miles. Don't forget your units on the word problems. Okay. And we can plug that back in to make sure. 3.5 plus 5.5 is 9, plus 0 is 9, plus 5 is 14, plus 11 is 25 divided by 5 is 5. Worked out pretty good. The formula D equals 1/2 N plus 26 relates to the nozzle pressure in pounds per square inch of a fire hose and the maximum horizontal distance the water reaches D in feet. How much pressure is needed to reach a fire 50 feet away? They gave me 50 feet. In feet is a D, so I know D is 50. So I'm going to plug that in. I'm going to say 50 equals 1/2 N plus 26. I'm going to get N by itself, so move the 26. Okay. Now you can do this a couple of different ways. It's multiplying because they're right next to each other by 1/2. So you could go ahead and divide by 1/2 on both sides, which is kind of an interesting thing. So let's look at that one. If we divide by 1/2, okay. 1/2 on top, 1/2 on bottom, cancels to 1s, leaves us with N. Now, 24 divided by 1/2. We never divide by fractions. Remember, we stay, we change, and we flip it over. 24 times 2 is 48, so we get 48, and that's supposed to be pounds per inch squared. Okay. Now, another way to look at that is 24 equals 1/2 N. Well, I put that over 1 and I do the multiply. It gives me 24 equals N over 2. Well, over 2 means divided by 2. So if I multiply this side by 2 and I multiply that side by 2, it's still equal. Whoop. Move to the next page. The 2 on top, 2 on bottom reduces to 1s, leaves me with N. 2 times 24 is 48. Still get the same answer, just different ways to do the math. Okay. Unit analysis to model real-life problems. When you write an equation to model a real-life problem, you should check that the units on each side of the equation balance. For instance, back in example 4, notice how the units match. Okay, 5 miles per day. The per is the divide sign, and over here we had miles on top, we had days on bottom, and the per is the divide sign, so it matched miles and day, miles and day. Some problems will throw you for a little loop there. All right, your school's drama club charges $4 per person for admission to a play. The club borrowed $400 to pay for costumes and props. After paying back the loan, or losing, or going down, or subtracting $400, the loan amount, the club has a profit of $100. How many people attended the play? Well, it's $4 per person. Okay, you figure out that's how you get your total that you make, and then we're going to take off the $400 we borrowed, and we're supposed to get $100 profit. So we add the 400. You get 4p equals 500. Divide by 4. P equals, let's see, 500 divided by 4. 4 goes into 5 once, which is 1. 10 is 2 times, which is 8. Minus is 2. 0. 20 goes 5 times, so 125 people.